Hello everyone and welcome to September's DevOps Playground. We are in the Global Logic London office, and for those with me in the office, quick technical talk. Fire exit will be around there when I show, or if you go around all the meeting rooms, and the gathering point will be right next to the mayor's office. So in case of fire, please meet me over there, and yeah, run towards the exit. That's the best I can do. DevOps Playground, for those who haven't joined us in the past, we try to share everything DevOps and more with the approach of hands-on learning. We learn by doing. We like to do stuff, break stuff, and play around with stuff. So we try to keep it in the format of 15 minutes presentation and 1 hour or more of hands-on workshops. We provide the infrastructure, so whatever you need to complete the lab will be provided if you're registered. If you're not registered, please shout. We'll help you anyway. Just a few useful things for those joining online. All the links should be below the video, so that's for the README, for the lab infrastructure, and so on. Again, if you need any help, shout in the comments or join the Slack channel. We will have some people trying to help along the way. If you got any questions as we go, please shout, please stop us. I know sometimes you're a little shy to stop everyone, but that's fine. We're here to help, and we want everyone to enjoy it at its own pace. We got some time. At the end, we'll have some pizza and networking. So yeah, hopefully everyone will enjoy it. Yeah, we try to keep that space for the community. Global Logic is keen to sponsor this event, but we try to keep it community oriented and just learn and build cool stuff. Today we got hands-on with SQS, Lambda. We'll also touch on API and SES.
SES.
Yep. Kizar, one of our DevOps dev consultants, sorry, will lead that session. Also known in some among friends as K-Dog. So without further ado, I'll leave the mic for him and let him bring you to today's session. Hope you all enjoy it, and see you next month. Yeah, good luck with the labs.
Right. Yep, are we good to? Ooh, feedback. Hi everybody, I'm Kizar, and I'll be doing the playground with you guys today. So a bit about me: I'm a delivery consultant at Global Logic, and I work in the development capability. So yeah. So what I wanted to talk to you, share with you guys today is how to build a scalable application that is. And we're going to be focusing on serverless technology. So how can you build something fast, cheaply, and something that's scalable? And that led me down to these topics, so Lambda and SQS mostly. So when you build for scale, you especially say if you work for a sort of like a small startup or something like that, where you don't have a lot of capital, you can use serverless to really accelerate your development. So serverless architecture, for those of you who don't know, refers to when like a cloud provider is responsible for provisioning all the infrastructure, maintaining it, and scaling it under the hood for you. And that really relieves your developers of all the burdens of basically deploying, configuration, and all that stuff. So that means people in all your developers can focus on the main stuff, which means product development, coding, business logic. And that can really accelerate development times, really cut down your costs. So what we're going to be learning about is how we can decouple different services in your system to make them work more smoothly the way you want it to, so you can have more control and more flexibility over how events happen in your system. And how you can make your services more fault tolerant. So yeah, so that's what we're going to be focusing on today. So let's talk about some of the technologies we're going to use today to build what we're going to build. So the first one is API gateway. So again, everything over the internet, is always it's the way data is transmitted over the internet is you're making API calls. So we're going to be using API gateway, which is an AWS service, to make our API. So what this service does is allows us to make and create, publish, and maintain and monitor APIs at scale. So that means we can quickly set up an API and have people talking to our application. And this service, you can set up many kinds of APIs. So you can set up a RESTful API for those of you who are used to REST. You can even do WebSockets. So if you're doing a streaming, like a video streaming or live data streams, you can have WebSockets as well. You can just have a simple HTTP API. So there's a lot of stuff to choose from. And you can really quickly deploy different stages of your application, test them, and release them with new versions. Again, the main take here is you can scale really fast. You don't have to worry about the scaling bit. AWS takes care of the difficult aspect of scaling, and so that's why we're going with API gateway. And again, if you're worried about cost, you're only paying for the calls made to your API and the data that's being transferred out. So it's just pay for what you use, and that's what you want, right? The second thing we're going to be using is AWS Lambda. And for those of you who don't know what AWS Lambda is, it's a service where you can just write code and run it without having to think about servers. How do you deploy this code? Where is this going to sit? You can just write a code and basically say, hey, like if something happens in my architecture in my system, make it run this code and do something. And that can really, again, speed up your how you can release your functionality, how fast you can come out with new features, and you can really build a reactive app. So it's it's an event-driven service. So anything that happens in your AWS system that's an event, you can react to that and do something. And again, it's pay for what you use. So it can be really cheap to have a Lambda service rather than provisioning like a virtual machine that's running all the time and maybe not being used that much, but you're still paying for that virtual machine to run. So a really good option. And we're also going to be using SES. So SES stands for Simple Email Service. And as the name implies, it's for emailing. So we're gonna use this to basically email people. And what this allows us to do is send emails. So if something happens, we can send an email. And this allows us to send emails without having to actually have an on-premises SMTP server. So all of basically the complications of having SMTP service running on-prem, we don't have to worry about that. And what we can do is we can send bulk emails, we can send like one-off notifications to different users based on something that's happening in your, based on some event. So maybe they're registered for something, maybe they've bought something, and we can send them an email. And again, like everything serverless, it's pay for what you use. So I think that's fair, right? I only want to pay for what I want to use. So yeah. And SQS. So we're going to be using SQS as well. And what SQS stands for is Simple Queue Service. And what this service does is it's essentially queuing up messages that happen in your system, and it's storing them so they can be consumed later. So think of it like a post box, like when you get mail, and it sits in there, and then when you're ready to check your post box, if you remember, you can just open your mailbox and get all the mail out of it and throw them away if they're useless, or open them up and see what's inside. So SQS is also a fully managed service, meaning that you don't have to worry about how to deploy this. Like you tell AWS what configurations you want, how you want to set this up, and AWS takes care of the hard work of scaling, worrying about how this is going to work, where these messages are going. All you have to do is just tell AWS what you want, and they will worry about everything else. And you have two queues to choose from. So we have a standard queue, which offers unlimited throughput. So you can pretty much send an unlimited amount of messages into this queue, and it can handle that. And it offers at least once delivery. So sometimes you might get some messages that are duplicated coming to you, but you will not lose any messages. And that's because SQS is storing your messages across multiple servers and multiple regions, multiple availability zones. So that means if one of AWS's services go down, maybe there's a flood or I don't know, some zombie apocalypse, your messages are safe. So thank God for AWS. And we also have best effort delivery. Best effort ordering. So that means AWS is going to try to preserve the order of the messages that come in. So if message 1 comes in first, it will try to put message 1 first to be consumed. We also have the FIFO queue, so that's first in, first out. So that's where AWS is preserving the order of the messages. It guarantees that. But then it's not you're not getting an unlimited throughput. So maybe applications that don't really rely on super high traffic, you can choose this. So you get 300 messages per second per API call. So that's still pretty high. And you get exactly once processing. That means no messages in this queue will be duplicated. So if there's it will weed out any duplicated messages. So you don't have to worry about that. So you won't, for example, again, someone buys something, that's the message in the queue. You don't have to worry about sending the person 2 emails saying like, hey, your order's been confirmed. So that's useful. And again, first in, first out delivery. So if your application depends on, if it's crucial for you to keep the messages in chronological order, then this is the queue for you. But in this playground, we're going to be playing around with standard queues because we mostly care about throughput, and the order doesn't really matter. So some of the features that SQS offers are that you can encrypt the messages in your queues using AWS Key Management Service. So if it's sensitive data that you're sending across your service, you can encrypt it. So just in case if someone has access, they can't get access to this sensitive data. It could be people's personal data. So we have that option. It scales pretty much to the moon. So again, you don't have to worry about scaling. If you have a sudden spike in demand, again, they got your back. So they will take care of the scaling and manage the sudden spikes in demand. So this is really useful for a lot of companies. So, and they offer triggers as well. So if something happens in your queue, you can react to that. So if a message is put into your queue, you can then tell a service to start doing something with that message. So you don't have to set up complicated cron jobs or polling. A lot of that is taken care of by the triggers. And for example, you have a queue and you can't process something successfully. You don't want to lose that message. And again, they're what's it called? Redirect policies where you can say, hey, if I can't process this message successfully, maybe 4 times, 5 times, put in a dead letter queue for me to manage later that I can go in and check what's going wrong in my system. And then you can basically react to that. So again, a lot of sort of everyday use cases that maybe developers need in a production application, they're all there. And you also have SDKs available in all popular programming languages. So it doesn't matter if you do C#, JavaScript, Go, your service can talk to an SQS queue. So that's really useful. And if you're not familiar with AWS and you come from an Azure background, or you don't even use a lot of cloud services at all, you have the Azure queue storage, which is a very similar service that Microsoft Azure offers. Or you can use RabbitMQ, which is open source, but then again, you have to deploy it yourself. You have to configure yourself and make sure it's up and running. So yeah, these are some of the comparable services if you haven't heard of SQS, and if you've heard of these ones, they offer similar features. But why even use SQS? Like, why bother? It's just some fancy queue in the middle. Like, why bother? And the thing is, the focus of this is like we're trying to make a scalable service. That means maybe you suddenly have a high spike in demand coming in. Maybe you sell flowers, and on Valentine's Day you suddenly have a big spike in demand. How do you manage that? You want to scale up certain things in your application that need to scale up. You don't want to scale up everything at once, which is a problem you face in a monolith architecture. So message queues allow us to separate all our middle microservices into basically allow them to be completely independent, and we can decouple them. That means if service A so service A talks to service B, and service B needs to scale up, we can just put them in a queue, and whenever service B is ready, it can consume it and pass it on and do whatever you want. So it can really, really help your application, your whole architecture be decoupled from each other. So, and you can also improve fault tolerance. So say you have a new intern, and they have pushed dodgy code to this service, and it's just brought it down. And a couple people here are like, yeah, I've done that a couple of times. And what if that service goes down? That means that service is not running anymore. You've probably lost a bunch of events in your architecture, in your system, that you're going to lose forever. So that queue is kind of like a fail-safe in place that's going to queue up those messages, and whenever the service is healthy again, it can start processing them again and start doing what it's doing. So you won't lose anything. And it also allows you to run tasks in parallel in your service. So you can basically say, hey, like take some event and then do this and do that and do this at the same time. So you don't have to go sequentially because there's a queue in front of every service. So you can do stuff independent of each other. So again, the whole thing about decoupling. And you can also use a queue to really reduce downstream pressure on systems by queuing them up. So you can say, hey, like service B downstream cannot really handle this traffic, right? Maybe it's a really intensive, like compute-intensive application. It takes a lot of compute power and a lot of time. So you can queue them up and then consume them as you need to, which is really useful because you don't have to think about how you're passing messages around. You can just stick them in a queue, and then whenever that service is ready to consume, it can just consume them. Let's look at like a real-life example where you might use this, right? So again, we have just a little like a simple architecture diagram. So you're running an e-commerce site. Now there's a client over there on their laptop. They place an order. That's probably going to make an API call, and that's going to go to a handler. And that handler is going to handle the order. It's going to say like, okay, yeah, you've ordered this, okay. And then it's going to maybe make a call to a database to save to your orders. And then once the orders have been successfully completed, it's going to maybe publish something to SNS. So SNS is a pub/sub service that Amazon offers. So it will then pass that message along to multiple queues. And you could have a service that's going to send an email to your customer saying, yes, I've received your order. Thank you for ordering with us. And then there could be another service that's an analytics service. So maybe you're monitoring something, how people buy stuff, and doing some cool machine, like ML stuff on there. Maybe you want to see how much discount you could give to your customers to buy more stuff. So that could be a service running there. And you've stuck a queue on top of that as well. And you have an inventory service, which is monitoring how much stock you have, right? And as you can see over here, we've got these three services running independently because they're running in parallel. So if you look at that, if that goes down there, none of these will be affected because there's a queue in front of them. They're all receiving messages independently. So that's really useful for you to build a really robust and fault-tolerant system. So for example, if my inventory service goes down, it's no problem. I can still send emails off to my customers saying, hey, your order's been approved. No one's going to be affected by this, just a service. And then when you're ready to run your analytics service again, the messages persist in the queue. So no important business like logic loss there. So yeah, that's sort of an example that I would give, and like the advantages of using queues in your system. So what we're going to build this playground is a very stripped down version of what you just saw, right? It's going to be a little like notification system that an e-commerce site would probably use. So we're going to imagine like imagine you're working for a small e-commerce site. You know, they're just starting up. They're a scrappy little startup. You're there as a developer. You're a hotshot developer, and and the CEO comes up to you and says, "Hey, Black Friday's coming up. We need a proper notification service right now, like yesterday." And how do you deliver that? And we've got some tools under our belt, so we're like, we got this. No worries. We've got serverless, and we can develop this fast to scale pretty easily and pretty cheaply. So what we're going to do is we need to have an API, obviously, because that's how customers are going to talk to our service. We also need something to handle the order, so some code that's going to run to handle whatever order's been placed. And then we need a queue to basically say, like, okay, order's been placed properly. Now just send off an email whenever you want, because when you don't need to notify your customers instantly about their purchase. You can notify them 5 minutes later, 10 minutes later. It doesn't really matter, so as long as you notify them at some point within a day, right? So we can put a queue in front of that service, and we can really manage how many emails we're sending. And maybe your limit is 5,000 emails a day, so you want to make sure you really manage that, or 5,000 emails an hour, and you can really manage that with a queue, because the queue can queue up the traffic, and you can just consume that as you wish. So what we're going to do today is we're going to provision an SQS service in an AWS. That's the first thing we're going to do. Why don't we provision the API gateway first? It's because the way the dependencies work. So because the Lambdas depend on the queue. So first, we're going to have a queue, because everything revolves around the queue in this example. And then we're going to have a Lambda, which is going to push messages into this queue. But then the Lambda is going to be triggered by an API gateway. So we need an API, which handles any basically HTTP requests that were made. And then at the end, we're going to then process, we're going to consume messages, pull this queue, say, hey, any tasks for me, any emails to send off? And then we're going to send off those emails to those customers. So that is what we're going to build today. And before we get started, I know I've spoken for what seems like an eternity. Any questions before we start? Wow. Very satisfied faces in this audience. Nice. It's just, yeah. Silence. Nice. I love it. Cool. OK, so now we're ready to get our hands dirty with AWS. So I'm going to ask you guys to get your devices out and head over to lab.devopsplayground.org. Is that right, Patrick? Oh, Patrick's there. Is that right? OK. And I'm going to stop presenting. So once you've opened up that site, it should look like this. So labs.devopsplayground.org. And just make sure you have the repo as well. Does everyone have the repo? Just a show of hands, like, because just in case if you fall behind, there's a repo with instructions on there. There's a README. If you don't have the repo, you should have that in the description in the meetup link. So yeah, so when you go to labs.devopsplayground.org, all you have to do is put in your meetup username. If you don't know your meetup username, just go to the meetup website and go to your profile, and it'll show you your username, which is I think it's your display name, and you can just put that in here. So for me, it's just my first name, last name. I should probably not share this because it has my password on here. So yeah, if you don't know your meetup username, just go to meetup.com, sign in, and just check. If you haven't signed up with Meetup, just raise your hand and somebody will come and give you a username and password. Patrick is the guy for that. So yeah, I'll have some sips. I'll have some brewskis while I wait. There's a README. If you go to github.com and then search for DevOps Playground, if you search for DevOps Playground and it's hands-on with AWS building, this title if you can't see it. Sorry, yeah. So you're if you haven't signed up with Meetup, Patrick will Patrick will give you a username.
Yeah, he gave me one.
Oh, he gave you one now. So have you managed to get some details?
Yeah.
That's it. That's great. Awesome. So we'll just wait for everybody to get to where you are, and then.
So you said the repo is in the email we sent?
I think so. Yeah, it should be. If you don't have it, I can send you a link. We can post a link on the YouTube chat as well, if anyone. Yeah. What's up? If you can't find the repo, I can send you the link in Slack.
Should we just stop at this point?
Yeah, stop at this point for now. I was going to wait for everyone to catch up.
Here's the GitHub if anyone doesn't have it.
Oh wow, apparently I'm not registered either. Am I K-Dog? I'm not K-Dog either. I think I might need Patrick's help as well. Or is it no space? No space either. Apparently I don't have any. Yeah.
I'm checking that.
Yeah. We're checking.
Do we just do it, or do we do it along with you?
I would prefer if you did it along with me. If you want to do it yourself, you can do it yourself. Yeah.
Yeah, I'll
Try K-Dog.
K-Dog? No space? No white spaces? Hyphen, right? Like this?
Yeah, I think that's the OG.
Yeah, boy. Let's go. All right. All right. All right, I'm in. Please don't use my password. I'm going to switch.
We have a request from YouTube for you to sing while we wait for everyone to log in.
Yep. So what?
We have a request from YouTube for you to sing while we're waiting for everyone to log in.
We have a question from what?
From YouTube. I mean, Al.
Oh.
Requesting that you sing while we wait.
Oh, right, okay. All right. All right. Don't need to ask, I'm a smooth operator. Smooth operator. Okay, yeah. Let me just, so let's sign into, I'm assuming most of you are now set up. Let's.
Are we all good? All signed in?
All signed in, everybody? Everyone's happy? All right, let's sign in. All right. Oh.
Your password will be different from what's on the screen. I can change it.
No, I didn't change anything.
Oh, do you not?
I mean, you don't really need these URLs.
Your thumb hand.
Oh, oops, sorry. Cool. Yay. All right. How awkward would it be if I couldn't sign in? All right. So yeah, I'm assuming everyone is happy and signed into AWS. You're in the matrix now. Let's go. So I would recommend that everyone have like the repo open with them. So like just you could have it side by side if you wanted to, if it made life easier. I will for sure. Even though I wrote this, sometimes I forget. So first thing, like I said before, we're going to make a queue. So let's go to, on the AWS console, let's search for SQS. It's the first thing that comes up. Simple queue service. Let's click on that. Cool. Wow, look at that. We've already got some queues here. Some people, some go-getters out there creating queues. All right, so let's click Create Queue. First step, so select standard queue. Again, we're going for a standard queue, not FIFO. And you want to name your queue. Again, naming convention is pretty important. So let's name our queue, whatever your Panda name is, underscore notification queue. So my Panda name is Fun Panda. So let's name it that. Cool. Got that. And let's talk about the configuration for a second, right? So we've got a standard queue. We've got the name for our queue. Let's talk about the configuration. So visibility timeout. So that's something that AWS does when a poller is processing, is polling your queue, and they've got the message. And there could be multiple threads that your Lambda has that's basically polling your queue. And there could be multiple services that are polling your queue. What SQS does is that it locks that message that's being pulled to other services. So that means other services can't see it. And you can specify the time for for a message that's being processed to be invisible to other services. So that's what visibility timeout is. And you want to set your visibility timeout to however long your processing might take. So again, if it's a really intensive, long process, you want to maybe set it to I don't know, like maybe 30 minutes or something. But in this case, we're just using SCS, so just 30 seconds is fine, right? More than enough to send off an email. Delivery delay. Let's talk about that. Delivery delay is how long it takes for a message that's been put in the queue to be seen by a consumer. So for example, you get a message. You can set it to appear to any pollers after a certain amount of time. Again, so that's just delaying the way messages can be consumed. And again, this is a way you can limit the rate of sort of tasks that you can process. Again, it's about managing how you can manage your costs on the cloud. So let's leave that to 0 because we don't want that. We want as soon as the message comes in a queue, we want that to be available to any consumer. And receive message wait time. So this is basically how long a poller is going to wait for a message. So imagine the Lambda is going to go to your queue and it's going to say to your queue, hey, are there any messages for me? And the queue is going to be like, no. So the Lambda is going to go back, and then the receive is going to wait. It's going to wait for the receive message wait time. So if you set it to 10 seconds, it's going to wait 10 seconds, and then it's going to go back to the queue and say, hey, are there any more messages for me? And it's going to repeat the same process. So if you set it to 0, that means it's going to constantly go back and forth. That means there's a lot of spin cycles wasted, which means, and AWS is going to charge you for that, the constant, because you're going to be checking the queue a lot. So that's a lot of compute power. Well, that's not great. So we want to maybe set it to 10. 10 sounds decent. The maximum amount is 20, but we'll have a 10-second interval when we check every messages. And just for your information, AWS counts anything above 0 seconds long polling. So that means your long polling is when you wait for a message you're sitting there waiting for a certain amount of messages. So in this case, for our use case, 10 seconds is enough. And that can really cut down our AWS bill. Let's carry on. So like I mentioned before, you can encrypt all your messages. So if you're transmitting a lot of sensitive data, you can encrypt them. But in this playground, we're not going to do that because we have limited time. So let's just disable that for now. So no, disable encryption. And access policy, again, basic. Don't worry about that for now. This is just a demo. We're not going to have any dead letter queues as well, so no redrive policy, no dead letter queues. Again, this is a little demo. But in a production app, you would want to not lose any messages. So you would have a dead letter queue. And that's it. Just click Create Queue. Voila. There you go. We got a queue here. Let's carry on now. So now we've got a queue. Now we need a Lambda function to send messages into this queue.
Some of us got access denied.
Access denied. So access denied? All right, okay.
We just partner up with someone that can do it.
Yeah, sure. So that's fine. Access denied.
You might have access denied to some services which are not part of the lab, or if you're in the wrong region.
What
you're getting
region
access
should they
denied
be?
Yeah.
to the right region.
Oh, what region should we?
It should be Ireland. Sorry, I should have mentioned that at the start. Ireland. Good old Ireland. So, yeah. If it's not Ireland, are you still on it? EUS1, yes, that's the one, yes. EUS, if you're on, EUS1, that's Ireland. And if you try that region, hopefully it should work.
Yeah, that works.
Awesome. Cool. I'll wait like a couple more seconds. So everyone's got a queue now, right? Sweet. Now that we have a queue, now we can have a Lambda to send messages to this queue. So let's, I would say I recommend opening a different tab. So let's duplicate this tab, because we're gonna have to go back to this to the queue tab anyway. So let's just duplicate the tab, and again, in your AWS console, let's search for Lambda. So once you're on the Lambda homepage, you can see this bright orange, oh, not bright orange, just a regular orange button. Click Create Function. We're going to select Author from scratch. So we're going to do this by scratch, because we're super cool developers, And then you want to again name your function as it says in the repo, whatever your Panda name is, _order _handler _lambda. It's a handful, but. And the Panda is Fun Panda. There we go. Yeah, we're going to be writing our Lambda code in Nodejs, so in JavaScript. If you guys don't like JavaScript, too bad. I'm sorry. But it is what it is. So Nodejs 16, and we're just going to select x86 architecture. And then you want to click on permissions. I'm just going to wait for people to catch up until they get to permissions. So yeah, once you're on permissions, we're going to select use an existing role. So we've made you guys a role here with all the right permissions you need to carry out this lab. But if you were starting from scratch, you'd have to make a role and attach policies to it, but we've done the work for you. So when you select using existing role, there'll be a text box, and you can just select Panda order handler Lambda role. So Panda order handler Lambda role. And this role basically allows us to talk to SQS queues. So once you've selected the right role and everything, you've named your Lambda function, you can just click Create Function, and that'll just tell AWS to create a Lambda function for you somewhere that's running somewhere. And as you can see, it creates that function for us, and we have like a little editor here where we can write the code for this function, right? Before we carry on, let's go into configuration, right? And inside, so if you click on the configuration tab on your Lambdas page, click on configuration and then scroll down to environment variables on the left. So what we're going to do is we're going to set some environment variables for this Lambda. So click on environment variables and click on edit here. And you want to add an environment variable. And the environment variable we're going to set is q, all caps, underscore URL. And what the value of this environment variable is going to be is the q URL of the queue you just created. So remember I told you to duplicate a tab? So go back to the tab you just came from, where you just created the queue, and you want to copy the URL of the queue that you just made. So it's right on the home page, right in the middle, where it says URL. Copy that and paste that as the value for all caps q underscore URL. Boom. I'm going to save that. And it's there. So that means when we write any code, we can have these environment variables and we can just reference these environment variables rather than hard coding stuff in our code. So there you go. That's our Lambda created. And it has, so yeah, there you go. So let's now make, so what's the next step in this, I guess, in this playground? We've got a queue. We have a Lambda that can put messages into a queue. Now we want the whole world to be able to talk to our service. And the way to do that is an API. Let's go back to our AWS console and search for API gateway. So as it sounds, API gateway. Click on that. And we've got API gateway. As you can see, some people are ahead of us. Loved Panda. Nice. All right. So now let's click Create API. Okay. So now we have like multiple APIs to choose from. The most popular is like REST API, but we're going to go with HTTP API, and that's because REST API is a bit more, has more features. It takes a bit more, there's a more configuration to do. In the real world, I would choose REST API because yeah, it's got more features. But just for the purposes of this playground, and the time limit we have, we're just going to go with the HTTP API. So let's click on Build on HTTP API. Build. So it takes us to the next page, so where you're going to configure it. Let's name our API. So let's just call it whatever your Panda name is. So I was fun Panda underscore API, right? And we want to integrate. Now we can add integrations to this. So now this is an AWS service, and again, all AWS services integrate really well. So we can tell this API to connect to some other AWS services we've made in the past. Hint, hint, our Lambda function. So click Add Integration. When you click Add Integration, you're going to see this drop-down menu. So let's click on that, and you can see Lambda. So let's click on Lambda, and you can see the Lambda text box appear. So let's click on that, and you see all these like Lambda functions appear, right? So you want to select the one you created. So remember your Panda name, select the Lambda you created before. So it's going to be your Lambda name followed by order handler Lambda. So I was fun Panda. Let's look for fun Panda here. There you go. That's my Lambda there. So we're telling AWS, hey, like I'm making this API. I want to integrate my Lambda to this. So I'm going to give like a couple of seconds for people to integrate their Lambda, and then we'll carry on. So you can search your Lambda as well. So if you remember your Lambda name, just search in the text box and it will appear.
Here's the contact info for career.
Okay, Siri. Oh, jeez. Never really listens when I need her to listen. It's always when, yeah. All right. I'm assuming everyone's integrated their Lambda. I'll give it 30 more seconds. If anyone's stuck, raise your hand so someone can come help you as well. So If you're stuck, just raise your hand and we'll send Patrick over. Cool. So we've got integration. Let's click next. Now we can configure the routes in our Lambda. So routes are, how that'll be like your endpoint on your URL. So you can have a HTTP method. So in this case, imagine the order's already been placed. So we're going to do a put method because we're not creating an order. Say we're just updating an order. And the resource path, which is going to be the endpoint, is going to be your, let's call it order underscore status. So that's going to be the endpoint on your API that people can talk to over the internet. And again, it's already got the integration target, which is your Lambda. So when somebody on the internet makes a put HTTP request to this endpoint, it will direct it to this Lambda. So we're good. Let's carry on. So again, just to repeat, it's a put request, and the resource path is /order underscore status. So we can click next, and we can go to configure stages. Don't have to worry about that. Just keep it as default, and then click next again. And you can see, we can just create our API. Congratulations, you have an API. How easy was that? No Spring or Express or whatever people use. So yeah, and this is the invoke URL you've got here. So this is the URL to talk to the Lambda. So what we can do is we can use a API client. If you have an API client, you can use that, or you can use curl if you're used to curl. So if you look at the repo, there's a curl command which you just need to replace some stuff with. So you just have to replace your invoke URL. So let's go to our. I have an API client. So let's do that. Let's copy this invoke URL. So this invoke URL, we're going to say, we're going to go to invoke URL, and we're going to add order status, which was the route we set. You don't have to have any body on this. Remember, it's a put HTTP request. Any other request it won't handle it. And when we send off a request, it'll tell us, hey, hello from Lambda, because that's what the Lambda has in the code.
Sorry, what is this application that you use?
Insomnia. You can also use Postman as well if you like. Or curl? Yeah, I can use curl as well. So for those of you who don't have an API client, you can go to your if you go to lab.devops Playground, and you have a terminal as well. So you can have we provide you with a terminal emulator. So look at that. Yep, I forgot my password.
So we can just curl in the terminal that you provide.
Yeah, or you can use if you're familiar with if you've got a terminal on your machine, you can also do that. So I've provided a curl command here. If you want to use that, let's try that out. I'm just going to copy this. So it's a curl put request, and all we have to do is just put the invoke URL. So let me just go to the invoke URL again here. That's the that's a queue URL. We want the invoke URL, copy on the terminal, and you can just all you have to do is replace this. So let's go here. Replace that. Paste. Enter. Boom. Hello from Lambda on your Weddy terminal. So for those of you who don't have an API client. Leave. Actually, I'm going to keep that open just in case. Awesome. Yeah, so if anyone's stuck, if they can't get this HTTP request to work, raise your hand and someone will come and help you out. There you go. Good community going here. Shouldn't be case sensitive. I don't think so. Yeah. So again, big picture. We've got an SQS queue. We've got a handler Lambda. We've got an API. So what we just did, we just made a request via this, and the API just forwarded it to this Lambda, and just sent back, hello from Lambda. So we know it's working. Awesome. So I'm gonna go to the next step. So again, looking at our little diagram here. Done this, done this, done this. Now let's just update this code to actually do something useful, right? So now we're gonna update our Lambda. So let's go to our Lambda. So back to your AWS console, we're gonna search for Lambda again. So let's go to Lambda. Wow, there's a lot of Lambdas here already. Yeah, cool. So we're gonna look for your Lambda, and you can just search that by searching your Panda name. So I was Fun Panda here. There you go, back in our Lambda. And we're gonna update the code, right? So what we're gonna do here is inside the Lambda directory in the repo, I have very graciously written all the code for you. You're welcome. So if you go to send to SQS.js, you can pretty much just copy all this, and I'll explain what this code does in a sec. So let's just copy all this here and replace whatever boilerplate AWS gave us. Paste that, and we'll click deploy. So remember to click deploy once you've pasted the code, just so AWS can take it and update their servers. Yeah. I'll give people like a minute to do that.
Got your window too small, the deploy button disappears.
Oh, really? Amazon's UX engineers need to step up their game then. Yeah. Cheers. Okay, let's talk about this code here. So again, it's JavaScript. So if you're familiar with JavaScript, it should be pretty easy to follow. What we're doing is we're using the AWS SDKs. We do some config setup. So we say, hey, this is our region, this is the API version, and we specify an SQS client. So that SQS client is going to help us talk to the SQS queue we just made. This from line 5 to 13, that's a function I've made to basically handle any errors that we want to send back to the client. So if the request is not right, I can send back a 400 saying invalid or bad request. And then we have a handler. And this handler, so all Lambda functions are just handlers. They handle an event. And the event is passed as a parameter to our handler function, right? So we have, it takes three, it can take up, I think it take more than that, but right now we've got 3 parameters in our event handler. We've got the event itself. So everything in AWS is an event. It's just an event-driven, architecture. So we get past this event. We also get a context, and we also get a callback. The first thing we want to do, again, the event is JSON. So we can parse this JSON. We can now do stuff with it in JavaScript, right? It's really handy. What we're going to do is, based on what the client sends to us, so this may be an update about their order, we're going to generate a message, right? Because we're sending an email off. So we need to, based on the status of the order, we're going to send off a certain email. So we've got a simple switch statement saying, hey, if the order status is dispatched, then the message should be this. If the status is delivered, then we're going to send this off. Simple stuff, right? Simple switch statement. Otherwise, if it's anything else, then that means I don't recognize this. This is not a real order status. Send back a 400. Then we have then from line 41, we have parameters. And this is what AWS needs to basically process this message. So every message in a queue has message attributes. And message attributes are metadata about the message. So this could be like message ID, anything you can filter the message by. So for example, I'm putting in stuff like order ID, customer email, but you would probably have other stuff in there like order status as well. So I've got order status as well. So your Lambda can sort the message by order status. You can have different Lambdas doing different stuff. And then all we have is a try-catch block. So we say, hey, take this message, send it off to our SQS queue, and if everything goes well, send a 200 status. That means it's okay back to whoever made this request. Otherwise, send an error and just send back the error, whatever the error was. That's it. Simple as. And if you've noticed, inside on line 57, we've got a queue URL. So this is the queue URL I made you guys set as your environment variable. So this Lambda will read from that environment variable and it'll know the queue URL. So if you haven't set that queue URL in your environment variable, this Lambda won't work. It won't push any messages into the queue. So now that we got that working, and you've deployed this code on this Lambda, we can go back to our API client, or if you don't have an API client, you can use curl as well. So you can see I've got my invoke URL and I've got the order status, which is the endpoint which we send the code to. And if I go back to the repo, I need to send a body in this JSON. So in the request, there's going to be a body. So let's scroll down to section 4. I've got this JSON here, section 4, step 5. We can copy that, and we can just paste that in the request body. If you don't have an API client, I've already got a curl command for you here, right below it. You can just copy that and just replace invoke URL with whatever your invoke URL is. And let's talk about this. So I'm sending a put request to our API with this in my body. So it needs certain things. It needs an order ID. It needs a customer email. And it needs order status. So in this case, we're saying, hey, our order status has been dispatched. So imagine someone at the warehouse is scanning this. And they're going to scan this, and it's going to send this message to our API, which basically our backend is going to process. One thing is you need to replace the customer email with your email. So just put your email in. I'm just going to put my work email in here. Logic.com. Yep. So I'm just going to replace that with my work email. And that's gonna go to our API, and our API is going to forward it to our Lambda, and it's going to put that in the queue. Fingers crossed. We're going to find out now. So send that request off. You can send it off via curl or your API client. Send that off. Boom. Message sent to SQS. What a nice message to receive. 200 OK. Nothing better. And if you don't believe me, we can go back to the queue and check. So wherever you have the queue open, let's go to the queue, and we can click on send and receive messages. So if you haven't sent the request off already, I'm just going to leave this open. So this is what the body of the JSON looks like. So it's a put request to your API URL / order status. Remember to put your email in. I'll zoom in a little bit, sorry. Oh, it's not. So it's just it's a simple JSON object. You can keep the order ID as whatever you want it to be. Just replace customer email with your email. And uppercase dispatched as the order status. And send that as a put request to the invoke URL / order status. And you should receive a responsive message sent to SQS. Just gonna give people like a minute or two to complete that.
Is there any particular reason why
in my switch, give me a sec. So in my switch case,
Like order ID.
so yeah, so it usually I think right. So the convention of sending when you send JSON, like anything JSON over the internet, is it's always camel case. But params here, we're not sending that across the internet. We're literally sending that from our Lambda to SQS. So that's not really going across the internet. So that's Amazon's own convention. And they've chosen Pascal case for this. But JSON, usually JSON from your client to API is always like camel case. Yeah? Cool. So if you, once you've sent your message off with your API client or curl, you can go to your queue on an SQS. So if you search for SQS on the AWS console, you go to the main page of your queue, you can click on send and receive messages. And if you scroll right to the bottom, you pull for messages, and you can see, hey, look, there's a message here that you just sent. And the body of the message is, your order has been dispatched, because we set order status as dispatched in our request body. And if you go in details, or you can go to attributes, you've got all the attributes attached to it. So that's my email there, order ID, and order status. So this is all the metadata that I might need to process a bunch of messages. That's cool. So yeah, I'll click on that. So I'll go through that again. So go search for SQS on AWS. Go to SQS. Look for your queue, so it'd be your Panda name. So I'm Fun Panda. Click on your queue, and right over here, you can click on, right at the top, send and receive messages. When you go to send and receive messages, right at the bottom, you're going to click for pull for messages, and you can see the message you just sent via the API client is there. So things are working. It's looking good. It's looking good here. So what I'm just going to delete this message because, fine, I've seen it. Doesn't need to be processed. Cool. So if anyone's stuck, let us know. Someone will come in and help you out. If not, I will carry on. Okay. So going back to our little diagram here, we've got an API. We've got a Lambda that can send, Lambda that can receive messages from, that can basically an API that will forward events to a Lambda. Then the Lambda will put messages into a queue, and then all we need is the last step here, which is a Lambda that can take messages from the queue and do something with them. And in this case, we want to send off an email to the email specified in the message. Easy. So what we're going to do is step 5 in the repo. So we're going to set up an SQS poller. So let's go back to Lambda in our AWS console. So let's search for Lambda. Right, we go to Lambda. We can click Create Function. Now, AWS has done something really nice for us here. We can just select a blueprint. Because, again, a lot of people set up Lambdas to pull from queues. So AWS knows, like, hey, you probably need to pull from a queue, so I can set up this Lambda with all the right permissions for you. So we can select Use a Blueprint. In the Blueprints text box, we can search for SQS. If you search for SQS, you get processed messages in an SQS queue. Just click that, and we can click Configure. There you go. So now it takes you to configuring your Lambda. Same, here's the drill again. So just name your Lambda. Again, we have a naming convention. So in this case, it's going to be whatever your Panda name is, _ notification _ Lambda. So again, I'm Fun Panda _ I'm just going to copy paste. It's dangerous. Cool. And we're going to use an existing role. Again, Patrick has been very nice in provisioning existing roles. So if you click on existing roles, we're going to use the Panda notification Lambda role. So just click on that. You're going to click on the, so yeah, once you've selected the Panda notification Lambda role, we're going to go down to the next section, which is SQS trigger. So remember what I talked about? We're going to trigger this Lambda for every SQS message, right? So now it's going to ask you which queue you want to trigger this Lambda from. So search for your queue. So Fun Panda, so that's my queue right there. Make sure enable triggers is ticked. Batch size is the amount of messages your Lambda can handle at once. So if there's 10 messages, if there's like 20 messages, it'll take 10 out of there, and it'll leave 10 there for another service to handle it. Batch window, we're just going to leave that blank, and that's it. We're just going to create our function. So click create function. Boom. Bob's your uncle. We've got a Lambda here. And you can see over here, AWS has like a little visual representation. There's a queue here and triggers your Lambda. So I'll give people like 2 minutes to just catch up. So once your Lambda is created, you got a Polar Lambda now. All we can do is just in the repo, you can go to the Lambdas directory. I've written the code for the Polar here, so go to Polar.js and copy all that code and just paste that in the code editor in your Lambda. So let's do that. Oops. So let me just make this big. That's not right. It's copying everything here. There we go. So once you've copied the code that I've written in GitHub, just copy that over to Lambda, and we can just click deploy. And I'll talk you through the code as well. It's again simple JavaScript. So we're doing something similar. Again, we're importing the AWS SDKs, and we're just configuring the SES client. So SES again is the email service that we're using to send emails. And in our handler, we are taking the event and we're destructuring the body. So it's a JSON data structure. We just get the message attributes in the body because that's what we care about. And in the event, there's a records field which has all the messages on there. So it's just a list of messages. And for every message, we can then just send somebody an email. So we know the email we need to send. We know the destination, and that's customer email. So we can do message attributes, customer email .string value. That's how it appears in the event. And in the message, in the body of itself, we can just attach the body of the message. And we can even set the subject of the email. So we can say, hey, your order update, or you can make it more customized. And the source is going to be orders at DevOps Playground. So that's where you're going to receive the email from. And we've configured SES for you, so we've got a verified domain. If you were doing this yourself, you'd have to verify your domain, take it out of sandbox mode in SES, but we've done that for you. And again, a simple try catch. We're gonna tell the SES client in our code, say, hey, send this email off. If there's something wrong, please console log this error, and we can check this out later. There you go. So let's deploy that. So once you've clicked deployed, that should be updated. And let's go back to our to the repo here, and so that's it. So now we've got the whole thing ready. So we've got everything.
Can I ask a question from YouTube?
Yeah, sure.
It's not messing you up. But, using this architecture, will messages get lost if SQS is down? Either when someone when someone pays but their order message was not published to the queue, or the dead letter queue because the SQS is down.
So that is a possibility. It's a very slim possibility. So SQS SQS will store all your messages in multiple SQS servers in different availability zones. So there's so much redundancy that the likelihood of that happening, of SQS losing your messages, is very, very, very low. And that's why, again, people like to use services like this, because Amazon just engineered such a great product that you can something you can rely on. So hopefully that answers your question. Cool. So going back to that. So we have everything ready. We've got a Lambda that can pull our queue, you can handle and send messages off. So let's try it now. Go back to your API client, Postman, Insomnia, whatever you like, or you can use a curl command. So I'm going to keep the JSON body the same, and I'm going to send myself an email. So hopefully I should get an email as soon as I send this. So imagine someone at the warehouse is dispatching your product, they scan this barcode, and this will then send off an API, a HTTP request. So let's do it. Fingers crossed. Okay. And waiting for an email now. Ooh, I love that sound. Boom, and there you go. There you go, your order has been updated. Your order will be dispatched in 1 to 3 business days. So yeah, so try sending yourself an email. And what we can do here is, what if we've delivered? So let's try this out. Delivered, send. Waiting. Yay! There you go. So what if we send something off that's a dodgy order status? So let's say, like, I don't know, sent. And again, our Lambda can handle that because we've done some error handling in our Lambda. So there you go, a scalable email notification service for your cool warehouse that's selling some crap that people want to buy. So there you go, you've done it. And the CEO is super stoked on you, and you get a super big pay rise, and everyone's stoked on you. Party. All right. So there you go. Yeah, we're done. That's pretty much it. If anyone has any questions, now is your time to ask. Yeah, go for it.
I know you already said it, but I was concentrating on so many other things.
Yeah.
What would happen to that setup if you didn't have SQS? You fire your Lambda function, your API fires a Lambda function, gets that stuff, and then sends the email using SES.
So luckily, Lambda is such a scalable service. Sorry, I'll repeat the question. So what's your name? Phil. So Phil asked a really good question, saying, what if I didn't have the queue? So let me switch back to PowerPoint here. What if I didn't have the queue in the middle? What if just I had one Lambda that handled the order and sent off an email at the same time, right? Exactly. So, and the question is, so the answer is basically, if you did that, the good thing about Lambdas is that it can scale to the moon, right? That's one of the biggest advantages of Lambda. You're using AWS's resources, and they have a lot of resources. They've just got so many data centers everywhere. So you wouldn't lose any messages, but the thing is, you might want to throttle the Lambda. You might want to limit the amount of emails you send, because that's going to cost you a lot, right? So for example, we have a quota of, I think it's 50,000 emails a day or something. What if you don't want to what if you want to not exceed that quota? Because that's going to cost your business. And you can do that with an SQS queue. So you can put those messages and you can in a queue, and you can consume them at a rate you're happy with. You won't lose any messages, because again, Lambda is going to scale so much that it can handle your demand, but you might exceed some. It might cost you a lot, because again, you're not controlling the flow of messages that's going through your system. So that's one reason why you want to use a Lambda. I wouldn't say Lambda couldn't scale to your demand, but it's just having more control over your system, right? Thank you. Thanks. Good question. Thank you. Anybody else? Barnaby. Oh yeah, you guys, come on.
Is there any reason that you'd use ARM instead of the x84 to process your Lambdas?
I don't know, actually. I don't know if Lambdas optimize their runtimes for ARMs. I usually stick with x86, to be honest. I actually don't know. Any more questions? Ant.
Hey, Kiz, are the queues transactable? So say you were, in your function, you were going to update a database,
Yep.
but you wanted to send something to the queue, and you wanted them both to work or both to fail. Is there a way of doing that?
So you're saying you want to send a message to a queue and save to the database after the message has been taken out of the queue?
No. So at the same time. So you want it to go to the queue,
Yeah.
and you want to update a database. If it doesn't go to the queue, you don't want to update the database. So it's like a...
Yeah, so that is where your first handler would come in. So that would handle it, and you would, if it's successful, you could tell the handler to say, yeah, send it to the queue and then send it to the database. Otherwise, don't send it to the queue at all. If that answers your question.
Okay.
Yeah. Some online questions?
How does SQS handle disaster recovery? E.g., if any SQS is in WE and it was to go down, so any SQS instance would be spun up, would the Lambda connect to the SQS instance, and would no messages be lost in that process?
So as far as I know, AWS will, so for example, if the whole region goes down, then you might be in trouble. So for example, if the whole of Ireland region goes down, please, let's hope that never happens. Then yeah, you might lose some messages in SQS, because they will distribute messages across that region, across multiple availability zones. If you want more reliability, you can have multiple SQS services running in multiple regions, but I think the likelihood of that happening is very low. Yep. Ant, go again.
Just, do you get poison queues?
Poison queues?
So
like deadloader queues?
if like I release a Lambda that's got some really bad code in it,
Yeah.
and then every time I read from the queue, I basically crash it. So I think in other messaging systems, if that were to happen after so many tries, it can put it in like a poison queue.
Yes, you can definitely do that. So you have what's it called, redrive policies, and you can customize your redrive policy to say, if this Lambda, say someone's deployed a really bad Lambda and it's not handling the messages properly, you can specify the number of times a message is unsuccessfully processed to put into multiple queues for you to have a look at later, and you can customize which queues you can have those messages sent to automatically as well. Oh, we have another one.
Yeah.
Cool.
Just following from that, how do you debug Lambdas? Is it something you build locally and then deploy? Or?
You can, you've probably seen over here that you can test your Lambda. So you can run tests. So it knows which services it's connected to, and you can kind of mock how to test it. And you can run tests on it. So if you click on test, and you can create test events. You can do a lot of stuff. Send custom messages via your API, and you can really play around with that. So I wouldn't say locally, but you would have to do it on the console. That's all I know how to do. So. Any more? Got some more online?
We did not see the SES setup. Can you walk us through what was done behind the scenes?
Sure.
What would be other prod applications of SQS apart from e-commerce?
Sure, yeah. So let me take the first part of that question, and let's talk about SES, right? So let's go to SES here on the console. Show my screen here. So Amazon Simple Email Service. I don't have the right permissions, but I'll talk you through it. So what you do here is you create an identity, and you can set up verified emails or verified domains, which basically Amazon knows that hey, I can send an email via this address or via this domain. So what we've done behind the scenes is we have a domain called DevOpsPlayground.org, and we've verified that, so Amazon knows that's ours. And what we've done is it puts everything in a sandbox mode. So if you can test stuff in sandbox mode, so you can send an email from a verified account to another verified account. That's to reduce spam or something like that if you want to do something dodgy. And then what you can do is you can tell Amazon, hey, like I'm ready, I've tested everything. Can you please take it out of sandbox mode and put it into production?
So, would you like to see that on the project?
Sorry?
Would you like to see the SCS on the project page? So you can talk about it. Would you
Sure.
like to see the console?
Oh, you want me to bring up the am I
No,
not?
so I can bring it up.
Oh,
Would you like me to put it on the project?
Yeah, sure, if you can, yeah. So I'll show you right now what we have. Yeah, James is doing his magic here. So yeah, the important thing is you have to take it out of sandbox mode. You have to take it into production, and you have to tell AWS what you're going to do with this email. What types of email are you going to send? Are you going to send marketing emails, updates, stuff like that? Because AWS really care about their reputation. If you're sending off spam emails with AWS, they don't like that, obviously. So you have to apply to take your SCS domain out of sandbox into production. So if
Sorry, I spoke so big about it. It's more buttons than I was expecting.
no worries, that's no problem. But yeah, we have a verified domain. Therefore, you have to do minimal setup because a verified domain can send messages to any email, and we don't have to. It doesn't have to be a verified email. You can send it to anybody. Yeah. So as you can see here, we've got So in our SCS dashboard, you can monitor how many emails you've sent. So like I said, we have 50,000 emails as quota. We've sent 16. That's a decent amount today. So it looks like a lot of people completed their lab. And yeah, and you can see if you go up, I think it shows how many verified domains and emails you have. And you have to apply for it to get out of sandbox into production for you to be able to use it properly. So that's the first thing you asked. What was the second part of the question?
What would be other prod applications for SQS apart from e-commerce?
Honestly, e-commerce, it could be anything you like, to be honest. It could be, for example, you have a little Twitter bot that's looking at scanning Twitter for images uploaded under a certain hashtag, and you want to process that image using like a machine learning model you have, and machine learning models, it needs some time to process an image. So you could have an SQS queue to manage that workflow. So anything where you want to limit the flow, make your infrastructure more resilient, or handle pressures more easily on your infrastructure, you can put in a queue. And also make sure that different parts you can easily separate different parts of your application. So if you have a microservice application architecture, and you want to make sure that these services can exist without each other, queues are your best friend.
We have another question.
Damn.
What is the difference between SQS and SNS?
Oh, I knew this was coming. So SNS is more of a pub sub kind of service. So you might have like an app that does a lot of stuff. In this case, for example, like an e-commerce application, people place orders. You could have an order placed event. You could have an order delivered event. And these are all little messages that are being sent across your application. So what SNS does is you can tell it to say like, hey, this event happened. Send it to the relevant people. Send it to the people who care about this event happening. And people can subscribe to certain events. So for example, in my case, I can show you in the over here. So for example, in this case, an order placed event happened. So anyone subscribing to this topic can receive this message. So SNS is really great for fanning out messages to multiple services. Whereas SQS is literally just to hold those messages that might be useful for a service. So very different, but interlinked uses.
Another question is, in terms of SQS, is there any other service that can be used that's outside of AWS?
Of course, yeah. So you can use RabbitMQ for this. So RabbitMQ is an open source software. I've used it before on a project. First time I used a queue actually. So it was really good. We deployed it in a container, so you can use that if you wanted to. But again, there's more configuration. You have to worry about scaling and all that stuff. But you can use RabbitMQ, a really good tool.
Thank you.
We got one more question from Ant.
You ready?
He's on fire tonight.
The emails that we were using tonight, can you have templated emails? So where you have like key values?
Yes,
Yeah.
yeah. So you can generate inside, if you go to the SCS console, if I'm looking, yeah. You can have email templates right here, and you can have certain templates for certain situations, and you can call that in your Lambda function and send your email across. Thanks. Yeah. Are we?
Sorry.
Oh, one more.
Apparently, this is the last one.
Wow. Okay.
Yeah.
Okay.
Last one from me. Can you explain some of the ways you can monitor queues in SQS?
That would be through CloudWatch, I would say. That's the best way to do it. So if you go to queues, again, CloudWatch is your friend on AWS. You can check the amount of messages. You can check the number of messages in your queue. So for example, monitoring, you can go right here and yeah, check for the number of messages coming in and all that stuff. So yeah, CloudWatch is the way to do it on AWS. And yeah, thank you everybody. Yeah, and hopefully that was useful. I just want to say a big shout out to certain people. So Wale and James for doing all the media stuff. Without them, this honestly we'd just fail. Patrick for doing all his black magic with the infrastructure. So all you have an AWS account. And Alex for the emotional support, and literally, and Jillian, and Rob for helping me with all the content. Yeah, and everybody who was involved in the dry run, thank you so much. And remember to like and subscribe. This video is not sponsored by anybody, but I am willing to take sponsors. So thank you, everybody.